Welcome back to We Dared Chemistry. In this lecture, we will spend our brain learning about Bohr's hydrogen atom model, its findings, so join us whether you are a student or a curious mind, according to Bohr's theory for hydrogen atom findings. The stationary states for electron are numbered n equals 1, 2, 3. These integral numbers are known as principal quantum numbers. The radii of the stationary states are expressed as radius of n equals n square into a0, where a0 equals 52.9 pm. Thus the radius of the first stationary state, called the Bohr orbit, is 52.9 pm. Normally the electron in the hydrogen atom is found in this orbit, that is n equals 1. As n increases, the value of R will increase. In other words, the electron will be present away from the nucleus. The most important property associated with the electron is the energy of its stationary state. It is given by the expression n equals RH into 1 divided n square, where n equals 1, 2, 3. Where RH is called Rydberg constant and its value is 2.18 into 10 raised to the power minus 18 joules. The energy of the lowest state, also called as the ground state, is E1 equals minus 2.18 into 10 raised to the power minus 18 multiplied by 1 divided by 1 square 2 is equal to minus 2.18 into 10 raised to the power minus 18 joules. Bohr's theory can also be applied to the ions containing only one electron, similar to that present in hydrogen atom. For example, He plus Li2 plus, B3 plus, and so on. The energies of the stationary states associated with these kinds of ions, also known as hydrogen-like species, are given by the expression n equals minus 2.18 into 10 raised to the power minus 18 z square divided by n square joules, and radii by the expression Rn equals 52.9 into n square and whole divided by z, where z is the atomic number and has values 2, 3 for the helium and lithium atoms, respectively. From the above equations, it is evident that the value of energy becomes more negative and that of radius becomes smaller with increase of z. This means that electron will be tightly bound to the nucleus. It is also possible to calculate the velocities of electrons moving in these orbits. Qualitatively, the magnitude of velocity of electron increases with increase of positive charge on the nucleus and decreases with increase of principal quantum number. This was the findings of Bohr model. Thank you for your attention. Keep studying with We Dared Chemistry.